For nearly 100 years, physics has been, well, it's been stuck. There's this massive contradiction sitting right at its heart, and it's stopping us from seeing the complete picture of reality. But what if I told you a single, pretty radical new idea could potentially fix it all? An idea that suggests the universe isn't quite what we think it is, and its number one rule is actually surprisingly simple. So let's take a look at a theory that, honestly, might just change everything. Just let this sink in for a second. What if the most fundamental rule of the universe isn't about energy or motion or forces, but it's just about slowing things down? What if every single physical law we've ever discovered is just a small part of a grander scheme to create delay? It sounds kind of out there, I know, but this one little idea is the key to this whole thing. Because without that delay, a reality like ours, one that unfolds over time, it might not even be possible. Okay, so before we can even get to the proposed solution, we really need to understand the problem. And in physics, it is a huge one. There is this fundamental conflict hiding in plain sight, right at the core of everything we thought we knew. See, on one side, we've got general relativity. It's beautiful, it's predictable, it governs all the big stuff, planets, stars, galaxies. And on the other side, we have quantum mechanics, the totally bizarre probabilistic rules for all the tiny stuff like atoms and particles. The problem? They are completely incompatible. One is smooth and continuous, the other is jumpy and random. One is certain, the other is built on pure chance. And in the places where they absolutely should meet, like inside a black hole, the math just completely falls apart. And this isn't just some abstract problem on a chalkboard, you know? This conflict leads to some genuinely baffling mysteries. Things like the measurement problem. Why does just looking at a particle seem to snap its reality into place? Or spooky action at a distance, where two particles can be connected across the entire universe, instantly. And of course, the famous black hole information paradox. Where does information actually go when it falls in? These aren't just little bugs. They are giant flashing red lights telling us we are missing something huge. So what if the answer isn't buried in some even more complicated mathematics? What if it's a simple foundational idea that we've just overlooked? This brings us to the proposed solution, a concept called the principle of delayed resolution, or PDR for short. The core idea of the PDR is, well, it's stunningly simple. It says that the primary purpose of the universe is to create delay. Think about it. Without delay, every cause and every effect would happen at the exact same instant. There would be no unfolding of events, no time, no structure, and certainly no observers like us. The universe, according to this theory, is fundamentally designed to meter out reality at a pace we can actually experience. This simple little equation you see here, this is the conceptual heart of the whole theory. It suggests that if you take delay, the universe's core purpose of slowing things down, and you combine it with the mechanics, all the physical laws we've discovered, what you get is our observed physics. This completely flips our perspective. It means physical laws aren't fundamental in and of themselves. Nope. They're just the tools the universe uses to create that all-important delay. So how does this actually work? Well, the theory proposes two distinct layers of reality. First, there's something it calls the photon instruction layer, or the PIL. You can think of this as the complete, timeless blueprint of the entire universe, like the whole film reel of a movie, just existing all at once, from beginning to end. Then, there's the space-time deployment frame, or SDF. Now, that's our reality. That's the movie being projected for us, one frame at a time, from that timeless film reel. The paper gives us this absolutely brilliant pinprick metaphor to help visualize this. Imagine our reality, the SDF, is just a big sheet of paper. A photon event, say light leaving a distant star and hitting your eye, creates two tiny holes in that paper, one where it was emitted and one where it was absorbed. But here's the key. The photon isn't traveling in the paper. The photon is the pin itself, a single timeless instruction in that other layer, the PIL, that connects those two holes from completely outside of our spacetime. The distance and time we perceive, that's just the space between the two holes on the paper. Okay, so it's a pretty radical new way to see reality, for sure. But the big question is, does it actually work? Let's see how this one simple idea starts to tackle those unsolved cases we were talking about earlier. Let's start with entanglement, Einstein's spooky action at a distance. The standard view is that two particles are somehow mysteriously linked, sending information faster than light. But in the PDR view, There is no spooky action. It's not spooky at all. The two entangled particles are just the two pinprick holes created by a single indivisible instruction in that timeless pill. Measuring one doesn't send some magic signal to the other, it just reveals one end of a fact that was already written down. The connection is perfect because, from the PIL's perspective, they were never truly separate to begin with. And what about the measurement problem? That weird idea that observing a quantum system forces it to choose a state. The PDR reframes this completely. There's no magical collapse caused by an observer. Before measurement, the system is just a set of potential instructions in the pill. It's in a state of indeterminate delay. The act of measuring it simply forces a final choice to be made, resolving that delay into a definite outcome that then plays out in our reality. The randomness we see isn't some fundamental feature of the universe. It's just our inability to know ahead of time which pre-written instruction was going to be chosen.
And it offers a beautifully simple solution to the black hole information paradox. The information, that film reel, it doesn't get destroyed when it hits a black hole. It's perfectly safe in the timeless blueprint, the PIL. What we perceive as information loss is just the projector stopping. The movie freezes right at the event horizon, but the film itself is completely unharmed.
Now look, a cool story isn't enough in science. A real theory has to be testable. It has to make bold, new predictions that we can actually go out and check. Predictions that could potentially prove the whole thing wrong. This is where we look for the smoking gun. And this is where the PDR gets really, really exciting. It makes concrete predictions that actually clash with standard physics. For instance, it predicts a tiny extra time delay for atomic clocks placed near very dense objects, beyond what even Einstein's relativity accounts for. It also predicts that entanglement experiments should show a minuscule delay that changes depending on the mass of the detector, something current theories say should absolutely not happen. These are real physical effects we could actually go out and try to measure. So let's look at that clock experiment a little more closely. You take two of the most precise atomic clocks on Earth and you sync them perfectly. Then you place a huge, dense slab of lead right next to the bottom clock. Now, general relativity already predicts a tiny time difference due to gravity, and we can calculate that. But the PDR predicts an additional delay on top of that, caused by the sheer mass density of the lead slowing down the local rate of instruction playback. If we were to measure that extra delay, well, that would be incredibly powerful evidence for this theory. So let's just step back for a minute. If any of these experiments actually prove the theory right, the implications they're staggering. It would force us to completely rebuild our understanding of reality, right from the ground up. I love this quote from the original paper because it really captures the elegance of the idea. The principle of delayed resolution doesn't try to unify physics with more and more complicated math. Instead, it offers a conceptual unification. It's saying general relativity and quantum mechanics aren't two different warring theories. They're just two different types of mechanics that both serve the exact same single purpose, to create delay. Now, of course, a theory this radical is going to face some tough questions. Is it unscientific to talk about a purpose for the universe? Well, not when that purpose leads directly to testable, falsifiable predictions. Does it add too much complexity? You could argue it doesn't, since it actually solves more paradoxes than it creates. And what about that timeless blueprint, the PIL, being unobservable? Well, the layer itself might be, but its effects, like that extra clock delay, should be measurable right here in our world. And this leaves us with a truly mind-bending final question. If this theory, or something like it, is right, then time as we experience it, that steady flowing river from past to future, isn't fundamental at all. It's just an emergent effect, a shadow cast by the universe's core need to create delay. So, if time is simply an illusion created by this process, what does that really mean for our past, our future, and our own existence within it?